So, guys, this is the part two of subtopic composite functions under mappings and functions. And this time around, we have three functions as opposed to the two functions we had in the previous video. Now, this time around, we have f of x being equal to x minus 3, g of x equals to 3x squared, and h of x equals 4x plus 3. Now, we are asked to find f of g, g of h, and f of g of h. All right. So the first thing we're going to do, of course, like I explained in the last video, is whenever you see f of g, it means you are going to take the entire g function and plug it inside f function. All right. So I'm going to just go ahead and write the f function first of all. That's just going to be I'll just put f and then write x minus 3. Okay, because I'm going to be plugging the g function inside the f function. All right, and which part of the f function is the g function going to be residing in? It's going to be residing where the x is at. All right, so now inside f function there is x here, right? And I'm going to be plugging g inside of it, and my g is 3x squared. So what I have here is just 3x squared minus 3. All right, that's just how it can simplify here. Although I think we can just factorize 3 out. We have 3x squared minus 1. All right, still the same thing as this. All right, so that's just simply that. That's going to be f of g. All right, and then moving on to letter b, we have g of h. It means I'm going to be taking the entire h and then dunking inside the g function. So I'm going to first of all write g function. My g function is 3x squared. All right, that's my g function, 3x squared. Okay, and then it says g of h, so that means I'm going to be taking the entire h and dunking it inside g function. So I'm going to be writing 3, and then whenever I see x, that's where the the h is going to be in. All right, and what's my h? H is 4x plus 3, so I'm going to be putting 3 and then 4x plus 3. All right, then all squared. Okay, and that's that. The next thing I will just do is to open this bracket. Okay, so I'm going to be having 3, open the bracket. How do I expand this function? I'll first of all square this expression, this term here, 4x, that's going to be 16x squared, plus I'm going to be doubling the product of these two. 3 times 4 is that's 12x, double that, that's going to be 24x, plus, and I'm going to be squaring this last function as well, 9. Okay, I'll square the first function. I'm going to be double their product, which gives me 24x, and I'm going to be squaring the last function. That's all. And then there's an existing 3 out here before. Okay, so if I open this bracket, 3 times 16, that should be 48x squared, I suppose. And then 3 times 24, that should be 72x. And 3 times 9, 3 times 9 is 27. All right, so that is a letter B, that's g of h. All right, then the third function, we have f of g of. Now you can do this one two ways. All right, f of g of h. It means I can take h and dunk it inside f of g, or take g of h and dunk it inside f. Any of the two is going to give us the right answer. So I'm going to go ahead and do the first one first of all. Take h and put it inside f of g. First of all, I've gotten my f of g, which is 3x squared minus 3. So my f of g already is what? 3x squared minus 3. All right, so my f of g of h, it means, like I said, I'm going to be taking h and putting it inside f of g. So now, what's my h? H is 4x plus 3. So put it inside f of g. So that's going to be 3, open bracket. Whenever I see x, that's where the h is going to be. So that's going to be 3. Okay, put h here. That's going to be 4x plus 3 all squared minus 3. All right. If you open this bracket, I think we did that sometime. Okay, that's 4x plus 3. If I open the bracket, I'm going to be having 16. So that's going to be 3, open bracket, 16x squared plus 24x plus 9. All right. And then, sorry, there's a minus 3 there too. Okay, let me bring it forward a bit. So if I open this bracket, I think I did that before. That's going to give me 48x squared plus 24x plus 27, then minus 3. Now that's going to give 48x squared plus 24x plus 27 minus 3, that's going to be 20. That's going to be plus 24. Okay, that is if I put h inside f of g. This is what I'll be getting. Like I said, I can as well decide to put g of h inside f. I should get the same thing as this particular function. So let me try and clean the board and see how that works out. Okay, so now I want to carry g of h. Oops, I've already cleaned up my g of h, but let's try and do it again. G of h means I'm going to take h and put it inside of g, right? Like I see the other time. So g of h, let's go do that again. My g is 3, and then put h inside that. H is 4x plus 3, 4x plus 3. Okay, that's g of h, and that's going to give okay, I just want to see if this is of course carry g of h. So take the entire, that's g3, and then all right, so g of h, I'm going to put in my entire h and put it inside of g. So I'm writing g first of all. G normally is 3x squared, Abi. So that's 3, and then wherever I see the x, I'm just going to be putting my h, all right? And then there's a square already, that's just that. And if you look very properly, I think we've done something like that before, this entire function here. So it gave us 48x squared plus 24x plus 27. All right. Now, we are now going to take the entire g of h and dunk it inside the function f. So now, I'm going to be having f of g of h. So I'm going to be writing f first of all. F is x minus 3. Okay, so which means whenever I see x here, I'm just going to put in my entire what? F of, g of h. So g of h is this entire function, the entire expression here. Okay, so put it whenever I see x, that becomes 48x squared plus 24x plus 27 minus this 3. Okay, you can put it in bracket if you want, minus 3. Okay, if you see, that's exactly what we got here. Okay, so that's going to become 48x squared plus 24x plus 27 minus 3 is just going to be what? 24, which is the exact same function we got when we did, the first one, which was we put h inside f of g. Now we are putting the entire g of h inside f. Both of them are going to give us the same answer. It just depends on how well you are able to interpret your question. All right. So see you in the next part of the question. Thank you, guys.